Hello, and welcome to Nightlight Science Stories. I'm glad you're here. Tonight we're going to drift slowly into the Milky Way, the galaxy we call home. Think of this not as a lecture, but as a quiet conversation at the edge of sleep, with the universe just outside your window. Imagine your room the way it looks right now. The familiar furniture, the soft glow of a lamp, maybe the faint light of a screen fading away. Outside, the night is deeper than it seems. Above your ceiling, beyond the roof and the clouds, the Milky Way is already stretching across the sky. If your walls could turn transparent for a moment, you would see it, a pale, misty river of light, running from one horizon to the other. People have given it many names, but tonight we will simply call it what it is to us, our galactic neighborhood, quietly shining while most of the planet sleeps. Now let's gently step outside in our imagination. Picture a calm lake, mountains in the distance, no city lights anywhere. The air is cold and still. Above that dark horizon, the Milky Way arches like a glowing bridge, reflected in the water so clearly that it feels as if the sky has doubled. From Earth, the Milky Way looks like a hazy cloud because we are sitting inside it, looking along the crowded plain of the galaxy. You are seeing the combined light of billions of distant stars, too many and too close together for your eyes to separate. To the naked eye, they melt into a soft river of brightness. For tens of thousands of years, humans looked up at that river of light and told stories about it. Some imagined it as a road for the gods, some as spilled milk, some as the smoke of ancient fires. No one knew it was a galaxy yet. They only knew it was beautiful, constant, and a little bit mysterious. The word galaxy itself comes from the ancient Greek word for milk. To them, the Milky Way really did look like someone had poured milk across the sky. Today we keep that name, but we have added new layers of understanding. We know that this Milky Band is a vast disk of stars, gas, dust, and dark matter. When astronomers say the Milky Way, they usually mean the entire galaxy, a broad spiral disk more than 100,000 light-years across. Our sun is just one star among perhaps a few hundred billion. From the outside, it would look like a glowing whirlpool of light, slowly turning in the dark. A light-year is the distance light travels in 1 year, about 9.5 trillion kilometers. When we say the Milky Way is 100,000 light-years wide, we are using numbers that don't fit easily in the human mind. So instead of trying to picture every detail, let the scale wash over you like ocean waves. Our own sun lives in one of the galaxy's spiral arms, a region sometimes called the Orion Arm or local spur. We sit about 26,000 light-years from the center, not too close to the crowded, violent core, not too far out in the thin, quiet outskirts. In a way, we live in a cosmic suburb. On a dark night, most of the stars you can see with your eyes are not scattered randomly through the universe. They are local neighbors within a few thousand light-years of the sun, sprinkled inside our spiral arm. When you see the bright band of the Milky Way, you are looking deeper, along the crowded thickness of the disk. For a long time, astronomers did not know the true shape of the Milky Way. It is hard to map a forest when you are standing among the trees. Bit by bit, by counting stars, measuring their distances, and tracking their motions, they built a picture of a flattened, rotating disk with spiral arms curling out from the center. Ordinary starlight is blocked by clouds of dust that fill the galaxy, but radio waves can slip through. In the 20th century, radio telescopes let us see past that dust. By tracing the radio glow from gas clouds, astronomers could outline the spiral structure and finally confirm that we really do live in a grand, rotating spiral galaxy. The Milky Way is more than just a flat disk. There's a central bulge, a round swelling of older stars, and a faint halo of star clusters and dark matter stretching far beyond the bright parts. If you could hold the galaxy in your hands, it would look like a glowing fried egg, a thick center and a thin, wide disk. Strangely, most of the Milky Way's mass is invisible. Stars in the outer regions orbit faster than they should if only visible matter were present. Something unseen adds extra gravity. We call it dark matter. We do not yet know exactly what it is, but we can feel its pull in the way our galaxy holds itself together. Inside this structure live hundreds of billions of stars. Some are tiny red dwarfs that burn slowly for trillions of years. Others are massive blue-white giants that live fast and die young. Around many of them, planets circle in darkness. Our Sun, with its family of planets, is just one ordinary member of this crowded city of stars. If we could walk along the Milky Way the way we walk along a city street at night, we would pass neighborhoods of different colors and moods. Regions rich in gas and dust where new stars are forming. Quieter suburbs of older, redder stars. Empty gaps like dark alleyways where very little light reaches us. In some parts of the galaxy, giant clouds of gas collapse under their own gravity, breaking into knots that ignite as new stars. We see these regions as glowing nebulae, painted in pinks, purples, and blues. They are both cradles and classrooms, shaping the planets and chemical elements that future life will need. Far away, in the direction of the constellation Sagittarius, lies the center of the Milky Way. From Earth, it looks like a crowded, dusty region, but in reality, it is packed with stars, gas, and something even stranger: a supermassive black hole, millions of times the mass of the Sun, quietly anchoring the galaxy's core. This black hole is not a cosmic monster chasing us. It sits at the very center, like a heavy stone at the bottom of a whirlpool. Stars and gas clouds orbit around it, but here in our local arm, we are safely distant. Its gravity helps shape the galaxy, yet our nights remain calm, filled only with its distant glow. When we look at the Milky Way, we mostly see stars, gas, and glowing clouds of dust. But astronomers are sure that most of our galaxy is actually made of something we cannot see at all. They call it dark matter. It does not shine, it does not block light, and yet its gravity shapes everything. How do we know it is there if we cannot see it? By watching how stars move. The stars in the outer parts of the galaxy orbit too fast to be held in place by just the visible matter. Something unseen must be providing extra gravity, like an invisible scaffold holding the galaxy together. Astronomers think the Milky Way sits inside a huge halo of dark matter, stretching far beyond the visible disk of stars. If you could see it, our galaxy would not just be a flat spiral, but a glowing whirlpool wrapped in a vast, ghostly sphere of invisible mass. It sounds mysterious, even a little eerie, that most of our galaxy is invisible, but in a way, it is comforting too. Dark matter has been here for billions of years, quietly holding the Milky Way together. While we worry about our small human problems, this unseen framework keeps everything in place. The truth is, we still do not know what dark matter really is. It might be a new kind of particle. It might be something even stranger. For now, it is a reminder that even when we think we understand the universe, most of it is still a beautiful question mark. So far, we have been looking at the Milky Way as it is now, but galaxies are not frozen pictures. They are living, changing systems. Stars are born and die. Orbits slowly shift. Even our whole galaxy has a future story, written across billions of years. One of the main characters in that future story is our closest large neighbor, the Andromeda Galaxy. Right now it is just a faint smudge in our night sky, far away. But it is moving toward us at hundreds of kilometers per second, pulled by the mutual gravity between our two galaxies. In about 4 billion years, the Milky Way and Andromeda will collide. It sounds dramatic, like an end-of-the-world movie. But galaxies are mostly empty space. When they merge, the stars will mostly pass by each other without direct collisions. The real drama happens in their shapes and orbits. If someone could stand on a quiet planet in the far future and look up, their night sky might be unbelievable. Instead of a single Milky Way band, they could see huge arcs of stars from two galaxies, tangled together like glowing rivers of light stretching across the darkness. After many passes and distortions, the Milky Way and Andromeda will eventually settle into a single larger galaxy. Some astronomers jokingly call it Milkomeda, a blend of both names. Our descendants, if they are still around, will live in a very different looking home in the cosmos. Inside the Milky Way, stars are constantly being born in vast clouds of gas and dust. Gravity slowly pulls these clouds together until they collapse and ignite. A newborn star is really a balance between the inward pull of gravity and the outward pressure of hot, shining gas. Stars do not shine forever. Small stars quietly fade and cool over billions of years. Massive stars burn fast and end their lives in powerful supernova explosions. In both cases, the process of dying returns material back into space, where it can be used to build new stars and planets. Around young stars, leftover gas and dust form spinning disks. Inside these disks, grains collide and stick together, slowly building up into rocks, then mountains, then whole planets. Every solid surface, every world with ground to walk on, is built from recycled star material. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of these were forged long ago in the hearts of stars and in the shockwaves of supernova. When you look at the Milky Way, you are also, in a quiet way, looking at the distant foundry that built you. It can feel humbling to realize how small we are inside this giant structure, but it can also feel strangely comforting. We are not separate from the galaxy. We are one small expression of it, briefly awake, able to notice and wonder about the place that made us possible. Because we sit inside the Milky Way, we can never step outside and take a simple photograph of it. Instead, astronomers have to map it piece by piece, measuring distances, motions, and spectra, then rebuilding the whole structure in their computers like a vast three-dimensional puzzle. Different telescopes each show us a different side of the Milky Way. Radio telescopes reveal cold hydrogen gas. Infrared missions peer through dust clouds to see hidden stars. X-ray observatories catch the fierce glow of hot gas near black holes. Together, they give us a more complete picture. All of this information starts as tiny bundles of light and radio waves, traveling for thousands of years through space. When they finally reach our detectors, we turn them into numbers, into images, into maps. From that faint data, we build stories about how our galaxy works and how it came to be. So tonight, while you rest, the Milky Way will keep turning overhead, slow and steady. Stars will rise and set. Clouds of gas will quietly collapse. New suns will be born in distant arms you will never see with your own eyes, and yet you now know they are there. Thank you for drifting through the Milky Way with me. If this quiet journey helped you unwind, you are always welcome to return for another slow, gentle walk among the stars. For now, let your thoughts grow softer, your breathing slow down, and let the galaxy watch over your sleep. As you drift farther from our familiar sun, imagine following its invisible path around the galaxy. Our star is not standing still. It is gliding through space, carrying Earth and all our memories with it, tracing a slow, graceful orbit that takes hundreds of millions of years to complete. Right now, as you listen, the sun is moving at roughly 200 kilometers every second, yet the night sky seems perfectly calm. Our senses are too small for these scales, so the Milky Way kindly slows the story down, letting us picture its motion as a long, quiet journey rather than a frantic sprint. If we could leave our orbit and rise above the galaxy, we would see the sun following a broad curve along one of the spiral arms. It is only a tiny spark among billions, but to us, it feels like the center of everything, the quiet hearth where our small corner of the universe stays warm. Spiral arms are not solid structures. They are more like gentle waves moving through the disk. Gas clouds slow down inside the wave, pile up, and form new stars. When you see a photograph of a bright, blue spiral arm, you are really seeing a snapshot of star birth spread over millions of years. Imagine drifting into one of these arms. The darkness fills with glowing clouds, some faint and ghostly, others sharp and bright. Inside them, gravity is quietly at work, pulling gas together, squeezing it until new stars ignite. From far away, it looks peaceful. Up close, it is a slow-burning storm. Some of those newborn stars will burn hot and blue, living fast and dying young. Others will glow more gently, like our sun, lasting for billions of years. Around many of them, disks of dust will swirl and clump, the first ingredients of new planets and maybe, one day, new listeners falling asleep to the stars. As we drift onward, the spiral arm thins out. The bright clusters grow rarer, and faint, lonely stars begin to dominate the view. Out here, space feels wider. The gaps between suns are larger, and the Milky Way's soft band across your sky would look thinner and more fragile from this vantage point. If you turned around now and looked back toward the center, the galaxy would appear as a glowing river of light. Billions of stars blend together into a misty band. Somewhere in that glow is the crowded heart of the Milky Way, wrapped in dust, hiding a secret that astronomers spent decades trying to confirm. At the core of our galaxy sits a supermassive black hole. It does not roam through space like a monster. It sits quietly, like a heavy stone at the bottom of a lake, shaping the motions of everything around it. Most of the time, it is surprisingly calm, almost modest for something so powerful. We cannot see the black hole directly, but we can watch the stars near it. They race around an invisible point, moving so fast that only a great mass could hold them in place. By tracing their paths, astronomers were able to weigh the darkness itself and say, yes, there is something immense hiding there. You might expect such a black hole to constantly tear things apart, but in truth, most of the time it simply waits. Only when gas or a wandering star ventures too close does it flare to life, heating material until it shines brighter than all the stars around it, then fading back into quiet again. From our place in the disk, we are safely far from that turbulent center. The light you see stretching across the dark countryside sky is mostly the combined glow of ordinary stars like our own, flocked together in the spiral arms, each with its own quiet story unfolding over billions of years. Beyond the bright disk, the Milky Way has a faint, extended halo. It is not a shining ring, but a sparse cloud of ancient stars, star clusters, and the ghostly pool of dark matter. If you could see it, the galaxy would look less like a flat coin and more like a glowing lantern wrapped in mist. Dark matter does not emit light, yet its gravity shapes the Milky Way. Stars in the outer regions orbit faster than visible matter alone can explain. It is as if the galaxy is sitting in an invisible bowl of extra mass, a quiet reminder that most of the universe is still hidden from our eyes. Scattered through the halo are tiny companion galaxies, like the small and large Magellanic Clouds. They are cosmic neighbors, slowly dancing around the Milky Way, sometimes feeding it with fresh gas and stars, sometimes being stretched and reshaped by its stronger pull. When you see a long stream of stars arcing around the Milky Way in telescope images, you are often looking at the remains of one of these companions. Over time, gravity gently tears them apart, wrapping their stars around the galaxy in delicate, stellar ribbons. From inside our atmosphere, with city lights and clouds, it is easy to forget how large and layered all of this is. Yet even with a modest dark sky, the band of the Milky Way still appears, a soft reminder that we live inside something vast, structured, and gently rotating around a hidden center. As you listen, your own thoughts may be drifting a little, the way stars drift along their orbit. That is all right. The Milky Way is not a story you have to hold tightly. It is more like a background melody, something you can return to whenever you look up and notice that soft streak of light again. Somewhere in one of those arms, on a small rocky world, a person is lying in bed, listening to a voice describe the galaxy they live in. To the Milky Way, that moment is almost nothing. but to that person, it might be a small, gentle anchor at the edge of sleep. Before we move on to other stories in future nights, let this one settle. You now carry a quiet map of the Milky Way in your mind, its disk and arms, its calm center and hidden halo. Whenever you need it, you can close your eyes and drift back here, to this slow turn among the stars. As we drift farther along the spiral arm, imagine the stars around us slowly changing. Some are young and blue, burning hot and bright. Others are older and more golden, like quiet lanterns. Together, they paint a soft gradient of ages across the night. If you could pause time and zoom in on any one of those stars, you would find a whole solar system quietly orbiting it. Planets made of rock, ice, and gas trace slow, graceful paths, circling their suns over millions of years. Some of those planets might be wrapped in thick atmospheres. Some might be frozen, with oceans locked under ice. Others might be warm, with clouds and oceans, and maybe even winds whispering across empty shores in the dark. When you look up at the Milky Way, almost every star you see probably has planets of its own. The night sky is not just a spray of light. It is a map of thousands of invisible worlds, each one quietly orbiting in the dark. Astronomers call planets around other stars exoplanets. We now know thousands of them by name and number. Some are so close to their stars that their surfaces melt. Others drip so far away that they barely feel any warmth at all. Some of the most intriguing exoplanets live in what we call the habitable zone, not too hot and not too cold. They might have liquid water, clouds, and seasons. We cannot visit them yet, but we can imagine their quiet landscapes under alien skies. Now slowly pull your attention back out. Leave those planets behind. Leave their moons, their rings, and their distant comets. Rise above them until they shrink to tiny points, just more dust inside the wide disk of the Milky Way. From this higher view, the galaxy looks calmer again, like a slow whirlpool of starlight. It turns so gradually that a single spin takes hundreds of millions of years. To us, it feels frozen. To the galaxy, we are just passing sparks. Near the center of this whirlpool lies one of the most mysterious players in our story, a supermassive black hole. It does not glow by itself, but the matter swirling around it can shine brilliantly as it falls inward. The one at the heart of our Milky Way is called Sagittarius, a star. It is millions of times more massive than our sun. Yet from here, it is just a quiet radio source hidden behind clouds of dust, humming softly in the background of space. Stars near the center race around that black hole at incredible speeds. Their orbits look like fast, bright loops when we watch them over many years. These motions are one of the strongest clues that something very heavy and invisible sits in the middle. Even though black holes sound frightening, you do not need to worry about ours. We are far, far away from the center. Out here, the galaxy feels gentle. The pull you notice most is still the familiar gravity of our own sun. As you lie there listening, you are orbiting the center of the Milky Way right now. So is everyone you know and everyone who has ever lived. Our whole solar system is a tiny passenger on this long, slow galactic journey. One full orbit around the galaxy takes about 200 million years. That means the dinosaurs, long ago, saw a different part of the Milky Way than we do tonight. Entire eras of life pass while the galaxy slowly turns. If you could draw our path, it would look like a long, gentle curve wrapped around the galactic center. Along the way, we pass by other spiral arms, brushes of gas, clusters of stars, and quiet, dark gaps where almost nothing shines. Sometimes we move through slightly denser regions of gas and dust. That can gently stir up our own cosmic neighborhood, nudging comets and leaving faint signatures in the record of our planet's history. The galaxy is not just a backdrop. It can shape our story. Far beyond the visible disk lies the galactic halo, a dim and ghostly sphere around the Milky Way. It holds old star clusters and a vast, invisible halo of dark matter that outweighs all the stars you can see. Dark matter does not glow, and it does not block light, but its gravity quietly holds the galaxy together. Without it, the Milky Way stars would fly apart. Instead, they stay bound in this slow, elegant spin through space. So as you listen, you are wrapped in several invisible layers of motion. You spin with Earth, you orbit the Sun orbits the galaxy, and the galaxy itself drifts through the larger universe. All of it happening at once, all while you lie still. It might sound dizzying, but out here inside one small arm of one ordinary galaxy, things are remarkably calm. The stars keep their distances, space stays mostly empty. And in that quiet, we get the rare chance to look up and wonder where we belong. Earth's rotation, orbit around the Sun, orbit around the galaxy, all schematic. As we travel inward, the sky above our imaginary ship gets busier. The number of stars around us increases, like moving from a quiet village into the center of a glowing city at night. More light, more motion, more subtle gravity pulling from every direction. The funny thing is that, from Earth, we cannot see the true center of the galaxy with ordinary light. Between us and the core lies a thick curtain of dust and gas. It absorbs and scatters starlight, hiding the heart of the Milky Way behind a soft, glowing veil. So astronomers learn to change the way they look. Instead of visible light, they listen in radio waves, observe in infrared, and even measure X-rays. Each new kind of light peels back another layer of the curtain, revealing a little more of what is really happening in that hidden core. What they discovered is astonishing. Near the center of the Milky Way, stars are packed together far more tightly than in our quiet neighborhood. It is like the difference between a lonely countryside road and a crowded downtown square lit by 1,000 lamps. At the very heart of this glowing city of stars, there is something even more extreme, a supermassive black hole called Sagittarius A star. It is millions of times more massive than our Sun, but it is not a cosmic vacuum cleaner racing around the galaxy. It simply sits there, quietly warping space and time. We know it is there because we can see the stars that orbit around it. Over many years, astronomers have watched these stars trace tiny, fast ellipses in the sky, whipping around an invisible point. Only something incredibly massive and compact could make them move this way. It is tempting to think of a black hole as a monster at the center of our story. But in reality, Sagittarius A star is simply another part of the Milky Way's life. It helps shape the flow of gas, the birth of new stars, and the slow evolution of the galaxy over billions of years. All around the galaxy, huge clouds of gas and dust slowly swirl and collapse under their own gravity. In some of these clouds, the material clumps together, grows denser, and eventually ignites into new stars. These regions are like cosmic nurseries, scattered along the spiral arms. Around many of these newborn stars, disks of leftover material spin like vast flat rings. Over time, grains of dust collide and stick, forming pebbles, then rocks, then entire worlds. This is how planets are born, quietly assembling from the leftovers of star formation. Our own Sun and its family of planets were once part of such a story. Long before Earth existed, there was only a cold cloud in a spiral arm of the Milky Way. That cloud collapsed, the Sun lit up at its center, and from the remaining dust, Earth slowly took shape. Not all stars live the same kind of life. Small, cool stars can burn steadily for hundreds of billions of years, like careful candles. Massive, hot stars, on the other hand, shine fiercely and burn out quickly, sometimes in just a few million years, ending in spectacular explosions. When one of those massive stars reaches the end of its life, its core collapses and the outer layers are blown into space in a supernova. For a short time, that single dying star can outshine the whole galaxy. And in that blast, heavy elements are scattered, seeding future clouds with the raw material for planets and life. The iron in your blood, the calcium in your bones, the oxygen in your lungs, and the carbon in your cells were all forged inside ancient stars and supernova. When we say that we are made of stardust, it is not just a poetic phrase. It is a quiet, literal truth about our place in the Milky Way. Again and again, stars are born, shine, and die. Their ashes mix back into the galaxy's gas, and from that enriched material, new generations of stars and planets emerge. In this way, the Milky Way is not a static picture, but a living system, slowly changing and renewing itself over cosmic time. Somewhere in one of those spiral arms, on a small rocky world lit by an ordinary star, a species arose that can look back at all of this and wonder. That is us. We are a tiny part of the Milky Way, but also a way for the galaxy to become aware of itself, at least for a little while. Of course, the Milky Way is not alone in the universe. It is part of a small neighborhood of galaxies, including the Andromeda Galaxy and many smaller companions. From far away, our entire Milky Way would just be one glowing whirlpool among many. In about 4 billion years, the Milky Way and Andromeda will come close enough to begin merging. It sounds dramatic, but the process is incredibly slow, taking billions of years, and stars are so far apart that very few will actually collide. It is more like two ghostly spirals passing through each other than a violent crash. Eventually, the two galaxies will settle into a single larger shape, sometimes called Milkomeda. If any distant descendants of humanity are still around to look up, their night sky will be filled with streams of stars and glowing arcs, unlike anything we see today. But that future is unimaginably far away. For us right now, the Milky Way is still the galaxy we know, a bright band across the night, a quiet home for our sun, and a backdrop for our brief human lives. It is enough for tonight just to picture where we are and to let that quiet sense of scale gently wash over us. If you could float a little above the Milky Way and pick out our sun from a distance, it would look completely ordinary. Just one quiet yellow star among hundreds of billions. And yet, for us, it is the center of everything we know, the lamp that makes our little corner of the galaxy feel like home. Now imagine drifting from star to star, like a slow, patient traveler. Around almost every star you pass, there are planets circling in the dark. Some are frozen, some are scorched, some are wrapped in thick clouds. The Milky Way is not just a galaxy of stars, it is a galaxy of worlds. Our galaxy's disk is about 100,000 light years across. That means if you could travel at the speed of light, it would still take you 100,000 years to go from one side to the other. The Milky Way is so large that our entire human story fits into its tiniest corner. When astronomers talk about the Milky Way, they often use numbers that sound almost unreal. Millions of years, billions of years, ages so long that a single human life is hardly a blink. And yet, in that tiny blink, we have learned to look up and ask what this galaxy really is. Inside the Milky Way, stars are constantly being born and eventually dying. In some places, dense clouds of gas and dust collapse under their own weight and light up as new stars. Elsewhere, old stars grow unstable and explode, returning their material to space, where it can be used to build the next generation. Every atom in your body, every element in your blood and bones, was forged in stars that lived and died long before the sun existed. When you look at the Milky Way in the night sky, you are not just looking at lights in the distance. You are looking at the place that built you, piece by piece. Think again of a quiet night, when the lights around you are low and the sky is clear. If you step outside or look out of a window, and you see that wide milky band overhead, you are seeing the combined light of uncountable stars. It is a reminder that our world is small, but it is not alone. From above, the Milky Way would look like a slow, graceful spiral, with long arms curling outward from the center. Those arms are not rigid structures. They are waves of higher density, where gas and stars bunch together for a while before drifting on, like traffic jams in the flow of the galaxy. The whole disk of the Milky Way is turning. Our sun makes a full orbit around this center roughly every 200 million years. In the time since life first appeared on Earth, the solar system has gone around the galaxy several times, tracing a slow path through changing neighborhoods of stars and clouds. When astronomers measured how fast the galaxy rotates, they found something surprising. The stars move as if there is much more mass in the Milky Way than what we can see. To explain this, they talk about dark matter, an invisible kind of matter that shapes the galaxy from the shadows. You do not feel dark matter when you walk down a street or lie in bed. It does not glow, it does not push on your skin, and it does not make a sound. But its gravity helps hold the Milky Way together. Without it, the galaxy's stars would fly apart into space like sparks from a fire. Closer to the center of the Milky Way, the stars are packed far more tightly together. If you could stand on a planet near the galactic core, your night sky would be filled with bright suns in every direction. It would never be truly dark, only a gentle, permanent glow. At the very heart of the galaxy sits a supermassive black hole, millions of times more massive than our sun. It does not roam around swallowing stars at random. Instead, it waits quietly, its gravity shaping the paths of nearby stars, like a heavy stone at the center of a spinning wheel. From where we are, tens of thousands of light years away from the center, that black hole is no threat at all. The space between us is vast, and the motions of the stars are slow and predictable. For our little planet, the Milky Way is more of a gentle cradle than a danger. Between the stars, the galaxy is not empty. Thin clouds of gas and dust drift in huge, complex shapes. Most of the time they are invisible, but when nearby stars light them up, they become glowing nebulae. In these clouds, the raw material for new stars and planets is quietly waiting. In some of these nebulae, gravity slowly pulls gas together into tight knots. As those knots grow heavier, their centers heat up until a new star ignites. To us, it would look like a light being switched on in the darkness, a new point in the Milky Way's vast collection of suns. Not all stars live the same kind of life. Small, cool stars can shine for hundreds of billions of years. Larger, hotter stars burn through their fuel quickly and die young. The Milky Way is full of stars at every stage, from newborns just leaving their nebulae to ancient suns slowly fading away. When a very massive star reaches the end of its life, it may explode as a supernova. For a brief time, that single star can outshine an entire galaxy. In that flash, new heavy elements are created and thrown into space. Those elements later become part of rocks, oceans, and even living cells. Far in the future, billions of years from now, the Milky Way will slowly drift toward our neighboring galaxy, Andromeda. The two galaxies will pass to each other and eventually merge. But because stars are so far apart, very few will actually collide. Mostly, space will just flow through space. In that distant future, long after our time, the night skies of whatever worlds exist then will look very different. But the quiet rules of gravity, light, and time will still be the same. The Milky Way's story will have turned a page, yet the universe will remain calm, patient, and full of new possibilities. As we keep drifting along this quiet galactic highway, the sun is not just circling the center of the Milky Way. It also gently bobs up and down through the thin disk, like a small boat riding slow waves. Every few tens of millions of years, we pass through the crowded midplane again, where gas, dust, and star formation are busiest. When people say the solar system takes about 230 million years to go around the galaxy once, they sometimes call that a galactic year. By that measure, dinosaurs lived only a couple of galactic months ago, and the entire written history of humanity fits into a tiny fraction of a single galactic day. The scale is almost absurd, but also strangely peaceful. Out in the spiral arms, gas clouds slowly collapse under their own gravity, lighting up newborn stars like small campfires scattered through the dark. Massive, hot blue stars live fast and die young, exploding as supernovae that stir and enrich the gas around them. In a quiet corner of one arm, our own sun formed about 4.5 billion years ago from just such recycled cosmic material. If you imagine the Milky Way without all its stars, you would still feel something invisible holding everything together. Astronomers call it dark matter, a mysterious form of mass that does not shine, but adds extra gravity. Without it, the stars in the outer parts of the galaxy would simply fly off into space. Instead, they keep circling with almost stubborn loyalty, as if tied by an unseen halo. Our galaxy is not truly alone, either. It lives in a small neighborhood of dozens of galaxies called the local group. Nearby, faint dwarf galaxies orbit us like tiny companions, while farther out the great spiral of Andromeda glows with its own billions of stars. From the right vantage point, the Milky Way and Andromeda would look like two slow dancers, very far apart, yet already moving toward each other. One day, billions of years from now, the Milky Way and Andromeda will merge. That sounds dramatic, but space between stars is so huge that very few individual stars are expected to collide. Instead, orbits will be stretched and rearranged. Gas clouds will crash together and form new waves of stars, and the night skies of any surviving worlds will change into something unrecognizably beautiful. By then, the sun will be an old star, past its quiet middle age. Long before the galaxies fully merge, it will exhaust the hydrogen in its core, swell into a red giant, and gently shed its outer layers. Whatever worlds circle it then will watch their sky turn a deep, strange red before the sun leaves behind a small, hot remnant and a faint cloud of glowing gas. All of that, though, is unimaginably far in the future. Right now, the Milky Way is in a long, quiet middle chapter of its life. Stars are still being born and dying. Gas is still flowing and cooling. Planets are still circling in dark, slow orbits. And on one of those planets, on the thin surface of a small rocky world, a species capable of wondering about all of this has recently appeared. When you lie back and listen to these stories, you are letting a very small part of the galaxy become quietly aware of itself. The atoms in your body were forged in ancient stars, scattered by explosions and gathered again into your bones and blood. The same gravity that shapes the Milky Way is holding you gently against the surface of the Earth as you drift towards sleep. So as this first journey through the Milky Way comes to a close, you can let the details blur a little and just keep the simple picture. A quiet spiral of hundreds of billions of stars. A modest yellow star in one of its arms. A small blue world circling that star. And somewhere on that world, you listening to the soft hum of the galaxy while the night slowly deepens around you. As we drift higher above the Milky Way, the galaxy begins to look less like a flat disk and more like a glowing island in a vast dark ocean. The spiral arms blur into a single soft halo of light, and the immense scale of it all becomes impossible to ignore. From this distance, the bright band you see in our night sky is revealed as just one thin slice of the whole structure. Down on Earth, it feels huge. Out here, it is simply one narrow line of stars in a much larger, rounded glow. It's a humbling thought. Everything you have ever known, every person you have ever heard of, every story humanity has told, all happening on a tiny world buried inside that narrow band of light. A single pixel in this grand cosmic photograph. And yet, from that tiny pixel, we have managed to look back at the galaxy that holds us. We have built telescopes, collected faint photons, and slowly stitched together this wider picture of where we live. In a sense, the Milky Way is a portrait we painted of our own home. If you listen closely, this perspective has a quiet message. You are small, but not insignificant. Your thoughts, your questions, your curiosity are part of how this galaxy becomes aware of itself. Without minds like yours, the Milky Way would remain silent and unknown. Now let's gently turn our attention to the invisible skeleton of the Milky Way. dark matter. We cannot see it, we cannot touch it, and yet it shapes the way the galaxy spins. Without it, the spiral arms would fly apart like sparks from a fire. Dark matter forms a vast, roughly spherical halo around the galaxy, extending far beyond the visible stars. The bright disk is like the glowing center of a lantern, and the dark matter halo is the clear glass around it, transparent, but absolutely crucial to the shape. When astronomers measure how fast stars orbit the galactic center, the numbers do not make sense if we only count visible matter. The stars move too quickly. Something unseen must be holding them in place, adding extra gravity. That something is what we call dark matter. It is strange, isn't it? Most of the mass that anchors our galaxy is invisible. The part that shines the stars, gas, dust, and glowing nebulae is just the frosting on a much larger, transparent cake. So as you look at images of the Milky Way, or imagine it now while you rest, remember that you are picturing only the bright skin of a deeper structure. Beneath the glow, a hidden framework of gravity is quietly holding everything together. Let's drift back down now, slowly, toward the familiar disk. As we sink through the galactic halo, the spiral structure becomes sharper again. The arms reappear like long glowing rivers, and the dense star fields of the inner regions begin to brighten beneath us. We pass back through the thick lanes of dust that crisscross the disk. These dark streaks may look like gaps, but they are actually full of raw material for future stars. Given enough time, gravity will squeeze these clouds until new suns ignite inside them. In this sense, the Milky Way is not a static picture. It is more like a slow, ongoing performance. Stars are born, they shine for millions or billions of years, and eventually they fade, explode, or quietly cool, returning material to the galactic stage. Right now, as you listen, this process is continuing all around us. Somewhere in the Milky Way tonight, a star is taking its first breath of nuclear fire, while another is releasing its last, scattering heavy elements into space for future worlds. Those heavy elements will one day form new planets, new oceans, and perhaps even new lives that will look up at their own sky and wonder about the glow of their galaxy, just as we do now. The story of the Milky Way is in many ways a story of recycling. As our imaginary journey continues, let's glide once more along the spiral arm that holds the sun. We move from cluster to cluster, passing young blue stars, older yellow ones, and the faint red embers of stars nearing the end of their lives. Each star has its own family of worlds, many of them completely unknown to us. Some of those systems may be dark and quiet forever. Others might harbor chemistry rich enough to eventually wake up, open its metaphorical eyes, and start asking questions about the sky. When you think about it that way, the Milky Way feels less like an object and more like a vast network of possibilities. Countless chances for complexity, consciousness, and curiosity to appear, flicker for a while, and then fade, leaving subtle traces behind. You, lying there and listening, are one of those flickers. You are a brief moment in the life of a galaxy. But during this moment, you have the rare chance to understand a little bit of where you are and what surrounds you. So as we begin this slow hour tour, imagine yourself gently descending back toward that small blue world, orbiting its quiet star, tucked safely inside a spiral arm. The grand glow of the Milky Way grows fainter behind you, like a distant city of light. Clouds gather under your feet, city lights reappear, and the familiar curve of the horizon returns. Above it all, the Milky Way is still there, stretched quietly across the sky, a reminder that even the most ordinary night is part of something enormous. The next time you see that pale band of light overhead, you might remember this slow walk through the galaxy. You might picture the core, the spiral arms, the dust lanes, and the quiet halo of dark matter holding it all together. And if this gentle journey helped you feel a little calmer, a little more grounded, or a little more curious, then the Milky Way has done something special tonight. It has not only lit up the sky, but also lit up a thought inside your mind. For now, let the details drift to the background. You don't need to remember every number or every term. Just keep this simple image, a great spiral of stars, turning slowly in the dark, and your small, bright life unfolding quietly inside it. Thank you for spending this quiet time with me. If you'd like to keep exploring the endless wonders of the universe together, don't forget to like the video and subscribe to Nightlight Science Stories before you drift off to sleep.